What if all the world's nuclear bombs detonated in outer space? Imagine for a moment the combined nuclear arsenals of Earth launched into the cosmos. Instead of targeting cities, these weapons are aimed at the emptiness between planets, stars, and galaxies. A terrifying thought, but what would actually happen? Would it be a cosmic light show? A catastrophic event ripping apart the fabric of space-time? The answer, like the universe itself, is a bit more nuanced. The immediate aftermath of this detonation would depend heavily on the location of the blast. Detonated within the Earth's magnetosphere, the region of space dominated by our planet's magnetic field, the effects would be most pronounced. Outside this protective bubble, the impacts would be significantly diminished. Distance, in the vastness of space, plays a crucial role. Regardless of location, the energy released by a nuclear detonation in space wouldn't produce a fiery explosion like we see on Earth. The absence of an atmosphere means there's no air for a shockwave to travel through. Instead, the energy would primarily be released as radiation, expanding outwards at the speed of light. This includes a blinding flash of light, a burst of heat, and a wave of deadly radiation, including gamma rays and X-rays. To understand the impact, we need to delve briefly into the physics of nuclear explosions. Nuclear weapons derive their power from nuclear fission or fusion reactions. These reactions release tremendous energy by splitting or combining atoms, respectively. This energy, released in the vacuum of space, takes on a different form than it would in an atmosphere. Without air to create a shock wave and a fireball, the energy from a space-based nuclear detonation would manifest primarily as radiation. This radiation, traveling at the speed of light, would spread outwards in a sphere, decreasing in intensity as it covers a larger and larger area. The initial burst of gamma rays and X-rays would be lethal at close range. However, the intensity of this radiation decreases rapidly with distance. This is due to the inverse square law, which states that the intensity of radiation is inversely proportional to the square of the distance from the source. In simpler terms, double the distance, and the intensity drops to a quarter. For a hypothetical observer situated a safe distance away, say, on the surface of the moon, the detonation of all of Earth's nuclear weapons in space would be a sight to behold. The initial flash of light, brighter than any star, would illuminate the lunar landscape. This flash, however, would be fleeting. Following the initial burst, there would be an afterglow, as the various particles released in the explosion interact with each other and with the interstellar medium. This afterglow, likely visible for hours or even days, would be a haunting reminder of the destructive power unleashed. The color of the light emitted would depend on the altitude of the detonation and the composition of the nuclear devices. Different elements, when superheated, emit light at specific wavelengths, creating a unique spectral signature. Analyzing this light could tell us much about the energy released and the materials involved in the explosion. The effects of this cosmic detonation wouldn't be limited to a light show. The explosion would generate a powerful electromagnetic pulse, or EMP. This pulse, a surge of electromagnetic energy, could disrupt or damage electronic equipment both in space and on Earth, depending on the blast's proximity to our planet. Imagine satellites malfunctioning, communication systems going haywire, and power grids experiencing widespread outages. While not an existential threat, the economic and social disruption caused by such an event would be significant. The world, increasingly reliant on technology, would find itself grappling with the fallout. Beyond the immediate impacts, the detonation would leave behind a cloud of radioactive debris. This debris, consisting of fission products and unspent nuclear material, would pose a long-term hazard to spacecraft and potentially even to future space exploration endeavors. Traveling at high speeds, these particles could damage sensitive equipment and pose a radiation risk to astronauts. Section 5. Our fragile atmosphere. Assessing the risks. One might wonder about the impact of this space-based nuclear detonation on Earth's atmosphere. Would it ignite the air, creating a global firestorm? Would it strip away our protective ozone layer, exposing us to harmful ultraviolet radiation from the sun? The answer, thankfully, is likely no. While the initial burst of radiation would reach Earth, the vast majority of it would be absorbed by the atmosphere. Our planet's magnetic field would also deflect a significant portion of the charged particles released in the explosion. The energy absorbed would be insignificant compared to the total energy the atmosphere receives from the sun every day. However, there could be localized effects, particularly if the detonation occurred within the Earth's magnetosphere. The EMP, as mentioned earlier, could disrupt radio communications and potentially damage electrical grids. The extent of these disruptions would depend on the altitude and yield of the detonation, as well as the robustness of our infrastructure. Section 6. Satellites in the crossfire. Perhaps the most immediate and noticeable impact of a nuclear detonation in space would be on our network of satellites. These satellites, orbiting Earth at various altitudes, are essential for communication, navigation, weather forecasting, and a host of other applications. A nuclear blast, even in space, could cripple this vital infrastructure. The intense radiation from the explosion could fry electronic components, rendering satellites inoperable. The EMP could induce currents in electrical systems, causing shorts and permanent damage. The debris cloud, traveling at high speeds, could collide with satellites, causing physical damage and potentially even triggering a cascade of collisions known as the Kessler syndrome. The loss of these satellites would have cascading effects on our technologically dependent world. Communication networks could go down, financial transactions could be disrupted, and military intelligence gathering could be compromised. The economic and social impacts would be felt globally. Section 7. The cosmic ecosystem long-term effects. Beyond the immediate aftermath, the detonation of all of Earth's nuclear weapons in space would have long-term consequences for the cosmic environment. The radioactive debris scattered across a vast area would become a hazard for future space exploration endeavors. Astronauts venturing beyond Earth's protective magnetic field would face an increased risk of radiation exposure. This debris could also pose a threat to future generations of satellites and spacecraft. Even microscopic particles, traveling at high speeds, can cause significant damage upon impact. The long-term effects on the space environment could be felt for decades, if not centuries. Furthermore, the detonation could have unforeseen consequences for our understanding of the universe. The burst of radiation could interfere with astronomical observations, masking distant objects and distorting data. It's a stark reminder that our actions have consequences, even in the vastness of space. The hypothetical scenario of all nuclear weapons detonating in space, while unlikely, serves as a stark reminder of the immense power we possess. It underscores the importance of nuclear disarmament and the need for international cooperation to prevent such a catastrophic event from ever occurring. The destructive potential of nuclear weapons is well documented. The bombings of Hiroshima and Nagasaki serve as grim reminders of the devastation these weapons can unleash. Detonating them in space while not directly harming human life would have far-reaching consequences for our technological civilization and the future of space exploration. This scenario also highlights the interconnectedness of our planet and the space surrounding it. What happens in space doesn't stay in space. It can have profound impacts on our planet and our lives. We must be mindful of our actions and strive to be responsible stewards of both our planet and the cosmos. The aftermath of such an event would likely lead to a global political crisis. Determining responsibility for the detonation, especially if it wasn't an intentional act, would be nearly impossible. Accusations would fly, trust would erode, and the already fragile geopolitical landscape could be pushed to the brink. The economic impact, coupled with the loss of vital space-based infrastructure, would further exacerbate tensions. Countries reliant on space-based technologies would face significant challenges. The potential for conflict, while not inevitable, would be high. This scenario underscores the need for clear international protocols and agreements regarding space. The Outer Space Treaty of 1967, while a step in the right direction, needs to be revisited and strengthened. We need a framework for accountability and cooperation to prevent misunderstandings and miscalculations that could lead to disaster. The detonation of all nuclear weapons in space, while a hypothetical scenario, serves as a wake-up call. It underscores the importance of nuclear disarmament, international cooperation, and responsible stewardship of both our planet and the space surrounding it. We have the power to choose a different path, one that ensures a safer and more sustainable future for all. The first step towards this future is continued dialogue and diplomacy. We need to bridge the divides between nations and foster a spirit of cooperation. The threat of nuclear annihilation, whether on Earth or in space, is a threat to all humanity. We must work together to eliminate this threat. Furthermore, we need to invest in space situational awareness. This includes tracking objects in orbit, developing technologies to mitigate space debris, and establishing clear protocols for responsible behavior in space. As we become more reliant on space-based technologies, we need to ensure the long-term sustainability of this vital domain. The vastness of space, often seen as a cold and indifferent void, can also be a source of unity. It reminds us that we are all interconnected, sharing this pale blue dot we call home. The challenges we face, from climate change to nuclear proliferation, require global solutions. The detonation of all nuclear weapons in space, while a hypothetical scenario, serves as a stark reminder of the stakes involved. We have the power to choose a different path, one that embraces cooperation, sustainability, and the peaceful exploration of our shared cosmic home. The future, while uncertain, is ours to shape.
Don't forget to like, subscribe, and share this video. That's all for Nifty Narration.